In our lesson today, we're going to talk about compound dependent events. All right, our last lesson was on independent events, and today we're going to look at dependent events. All right, when events were independent, that meant that the second probability was not influenced by the first probability. For today, with dependent events, this is when the second simple probability is affected by the first simple probability. Okay, we say that the events are dependent when this is true. Okay, and so what we're going to do, we're going to do a few examples. We're going to use a box of chocolates, okay, and in that box of chocolates, we have 4 caramel candies, 7 peanut candies, 6 cream-filled candies, and 3 chocolate candies. And we're going to start by finding simple probabilities first. Simple probabilities when you're looking for the probability of just one event. Okay, so we're going to find the probability of a peanut candy, a cream candy, and a caramel candy. Now remember that simple probability is a fraction. It's what you want as your numerator and the total number of possibilities in the denominator. So the first thing that we should do is figure out how many candies we had in the box. So we can go ahead and add these numbers up. 4 plus 7 is 11, and 6 makes 17, and 3 makes 20. So there are 20 total candies. So all of these simple probabilities are going to be out of 20. Okay, and now to find the numerators for each of them, well, we're just going to look and see how many of those certain types of candies there are. So the probability of getting a peanut candy, well, since there are 7 peanut candies, that's going to be 7 out of 20. To get a cream candy, okay, there's 6 cream-filled candies, so the probability is going to be 6 out of 20, which will simplify down to 3/10. And then for a caramel candy, there are 4 of those, so the probability is 4 out of 20, which will simplify down to 1/5. Okay, so when you're finding simple probability, you're only looking for the probability of one event. We're going to change it now over here by taking more than one candy, okay? We're going to take 2 candies this time, making this a compound event. Okay, so in the first example, we're going to find the probability of getting a chocolate candy followed by a peanut candy. And when we do these types of problems, again, to find the compound probability, we're first going to find the simple probabilities, and then we're going to multiply them at the end to get that total compound probability. So let's start by finding the probability of a chocolate candy. Okay, looking at my list here, 3 of them are chocolate, and there's 20 total candies, so the probability of a chocolate candy is 3 out of 20. Okay, we take that chocolate candy, we eat it. It's not going back in the box. That would be gross, right? Okay, don't put the candy back in the box after you've had it in your mouth. So instead of having 20 candies now in the box, our second probability is going to have to be out of 19. And these are dependent, okay? Because the second probability is being affected by the first probability, this is called a dependent event. We've changed the denominator. There's no longer 20 candies in the box. There's only 19 candies. So now to get the probability of a peanut candy, well, the first one we took was chocolate, so looking at peanut, there's 7 of those out of a total 19, so that's a 7 out of 19 probability. We multiply these together, and that's going to give us a total compound probability of 21 over 380, okay, and that does not simplify. Suppose that we wanted a caramel candy first and then a cream candy. Okay, so let's start by getting a caramel candy. The probability, there are 4 of those out of 20, so the probability is 4/20. We take that out, we eat it. So again, dependent. We're changing how many candies are in the box. Now we want to get a cream candy. Okay, the first one was caramel, so cream. We come here, there are 6 of those, and there's only 19 left in the box, so now the probability is 6 out of 19. We multiply those together. That's going to be 24 out of 380, but that will simplify down to 6 over 95. Both 24 and 380 were divisible by 4. Okay, in our last example, suppose that we wanted to get 2 chocolate candies in a row. Okay, so let's start with the first chocolate candy. I reach in, there's 3 chocolate candies out of 20 total, so that's a 3 out of 20 probability. Okay, we take a first chocolate candy, we ate it. So now we're going to get another chocolate candy. Now remember, there's not 20 in the box anymore. Now there's only 19 candies. Okay, and remember, Our first candy was a chocolate candy. So now we want another chocolate candy. There's no longer 3. If we ate one of them, now there's only 2 chocolate candies left. So our probability of getting a chocolate candy the second time is only 2 out of 19. We started with 3, we ate one, we're down to 2 chocolate candies out of a total 19 that are left in the box. Okay, multiply these together, and that's going to give us a probability of 6 out of 380. Both of those numbers are divisible by 2, so we can get a 3 out of 190 as our simplified compound probability. So when we talk about compound events, again, that's more than one event happening. So it could be 2 events, 3 events, etc. Okay, and they can either be independent or they can be dependent. Remember, independent, when one game or one probability does not affect the second. Okay, but with dependent events, that's when the second probability is affected by the first probability. So here's an example. We're going to start with independent events. All right, we're going to roll a die twice. Okay, we're going to roll a die once, and then we're going to roll a die the second time. These are independent events because the number that you get the first time does not change the numbers that you can get on the die the second time. Okay, so they're completely independent of each other. We want the probability of getting a 6 and then another 6. Okay, so let's find the simple probabilities first. The first probability of getting a 6 is 1 out of 6, since there's only 1 6 on the die and 6 total sides. Okay, I roll the die again. I want to get another 6. The probability again is 1 out of 6. I multiply them to get my compound probability, which is going to be 1 out of 36. The next probability I want, the next one, is an even number followed by a 5. So let's start with the probability of getting an even number. That's 2, 4, and 6. So 3 out of the 6 sides are even. Now I want to get 5 the second time I roll the die. That's going to be a 1 out of 6 probability. I multiply 3 6 by 1 6, which I get 3 36, and that simplifies down to 1 12. Okay, so my second probability was never affected by the first probability. On the dependent side, remember, when a candy is picked, it's going to get eaten. So the second choice is out of a total that has 1 less candy. Okay, so we're going to pick 2 candies in a row, just like what we were doing up above, and we're going to use the same box of candy that we had before. So the numbers are going to be the same. We want to get a peanut candy and then another peanut candy. Okay, so remember, back up here, okay, here's all of our candies. We had 7 peanut candies out of 20 total in the box. So my first probability of getting a peanut candy, okay, is going to be 7 out of 20. But remember, I'm going to take that candy out, I'm going to eat it. Okay, so now my next probability is only out of 19 because there's 19 candies in the box. And since my first candy was also a peanut candy, I've eaten one of these 7, meaning that there are only 6 left in the box. So the probability of getting a peanut candy the second time is 6 out of 19. I multiply these 2 probabilities together and I get 42 out of 380. And that will simplify down to 21 over 190. Okay, suppose instead we wanted a peanut candy followed by a cream candy. Okay, so to get a peanut candy the first time, we just set up here was 7 out of 20. Now I want to get a cream candy the second time. I know my probability is going to be out of 19 because I ate that first candy. And looking at my list up above for cream candy, that's 6 of them. So 6 out of 19 is the probability of getting a cream candy. This also, again, will give me 42 out of 380, which we set up above is 21 out of 190. So when you're doing compound probabilities, the first thing that you're going to have to ask yourselves are what kind of compound probabilities are you working with? Are they independent events or are they dependent events? So in our first example, we're going to flip a coin and we're going to roll a die after that. When you flip a coin, you could get heads or tails. Okay, no matter what you get on the coin, it's not going to change the numbers that are on the die. So these two are completely independent of each other. So these are independent events. All right, so let's figure out the probability of getting heads on the coin and a number bigger than 4 on the die. To get heads on the coin, okay, that's a 1/2, 1 out of 2 probability. To get a number greater than 4 on the die, that's the numbers 5 and 6. So that's a 2 out of 6 probability. And now to get the compound probability, we're going to multiply these together. A half times 2/6 is 2/12, which will simplify down to 1/6. Okay? In our next example, we're going to pick a marble from a jar that has 4 blue marbles, 5 red marbles, and 2 yellow marbles. The marble is not replaced after the first pick. Okay? So my number of marbles when I draw the second time isn't going to be the same as it was when I took out the first marble. So therefore, this second probability is going to get affected by the first probability, meaning that they are dependent upon each other. Okay, these are dependent events. So I want the probability of getting a blue marble and then a red marble. So let's start with the probability of getting a blue marble. The first thing I have to do is figure out how many marbles are there in the jar. 4 blue, 5 red, 2 yellow. 4 plus 5 is 9, plus 2 is 11. So my first probability is going to be out of 11. And to get a blue marble, there are 4 of them, so it's 4 out of 11. Now my next probability is only going to be out of 10 because the first marble was not replaced. I took a marble out. Now I want to get red the second time. There are 5 red marbles, so I'll put 5 out of 10 as my second probability. And we'll multiply these together, and that's going to be 20 out of 110, which would simplify down to 2/11. On the next page, we have sets of bags of marbles here, okay? And the bags of marbles are the same on both sides here, okay? So I've got my independent on the left, which means I'm going to replace my first marble. I'm going to take a marble out. I'm going to look at the color. I'll record it, and then I'm going to put that marble back in the bag. Okay, so these are independent because I'm going to keep the same number of marbles every single time. On the right side, these are dependent, without replacement. I'm going to take a marble, I'm going to take it out, and I'm not going to put it back in, and then I'm going to take my second marble. So I'm going to change how many marbles are in the bag for the second pick. Let's start with the independent side. I first want to get a black marble and then a white marble. So I'm going to first count up how many marbles I have in the bag. Okay, 1, 2, 3, 4, 5, 6, 7. There are 8 marbles. So you get a black marble. Okay, 1, 2, 3. That's 4 out of 8. Okay, now remember, I'm putting that marble back in the bag. So now for my probability of getting a white marble, it's also out of 8. And there are 4 of those. So we're going to have 4/8 times 4/8. Which is going to equal 16/64, and that'll simplify all the way down to 1/4. Okay, and remember, you can simplify early. 4 and 8 have a common factor. This can become 1/2. This can also become 1/2. 1 times 1 is 1. 2 times 2 is 4. If I do this as a dependent event, though, okay, black and then white, the probability of getting a black marble the first time, well, we said over here, that was 4 out of 8. 4 of the 8 marbles were black. But now when I take that marble out, I'm not going to replace it. So for the white marble, I'm only going to have 7 marbles left in the bag. 4 of them are going to be white marbles. And so I have 4/8 times 4/7, which is going to equal 16/56. And that'll simplify all the way down to 2/7. Okay, so again, I can simplify 4/8 down to 1/2. And then this 2 and this 4, numerator and denominator, they have a factor of 2 in common, so I can simplify that 2 again to a 1, and that 4 to a 2. 1 times 2 is 2. 1 times 7 is 7. With the next set, again, these bags of marbles are exactly the same, and in each case I want to get a black marble and then another black marble. Okay, remember on the left this is independent with replacement, on the right is dependent without replacement. Let's start with the independent side. Count your marbles. 1, 2, 3, 4, 5, 6, 7 marbles this time. So to get a black marble, it's going to be 4 out of 7. Since I replaced that first marble, to get another black marble, it's also going to be 4 out of 7. And when we multiply these together, that's going to give us a probability of 16 out of 49. On the dependent side, if again I want a black marble and then another black marble, the probability of getting a black marble the first time was 4 out of 7. And the probability of getting a black marble the second time, well, I didn't put the first black marble in the bag again, so now there's only 6 marbles. And the first marble was black, so instead of having 4 of them, there's only going to be 3. And so we multiply these together, and that's going to give me a probability of 12 out of 42. which will simplify down to 2/7. With the last two marbles that we have here, go ahead and punch your answers into the PlayPosit.